So in this exercise, we're going to track the weight of 3 friends over the course of several weeks. The table that's displayed right now is the data for Alan. So in week 0, Alan weighs 160 pounds. 4 weeks later, Alan's 168 pounds. So it looks like Alan gained weight from week 0 to 4, right? And then week 9, it looks like Alan's 178 pounds. So if Alan's on a diet, he's not doing well because he started at 160 pounds and he ended up at 178 pounds. So it says, does this data represent a linear function? Explain showing rate of change calculations. So the easiest way to do that would be to use the slope formula. If you remember, the slope equals the change in output over the change in input, or the change in y over the change in x. So that would look like the following. Right, so my change in output would be 168 minus 160 over 4 minus 0. That's my change in input. So I'm left with 8 over 4, which equals 2 pounds per week. So now I have to test this with another rate of change to see if my average rate of change is always constant. If it is, I know we have a linear function. So I'll pick another 2 points. I'll use week 9 and week 4. So you'll see I have the 178 minus 168, that's my change in output, over my 9 minus 4, which would be my change in input, and I'm left with 10 over 5 equals 2. So my average rate of change, or my slope, is always constant at 2 pounds per week. Okay, so I'll just write a little explanation here on the side. So here's my little blurb, or my explanation. Right? The data represents a linear function because the average rate of change, or slope, is constant. And at this point, we have 2 pounds per week as the average rate of change. Next, we're asked to write the linear equation in the form of y equals mx plus b. So remember the m, we've just found the m, right? The m is the 2 pounds per week, that's our slope. And the b is our y-intercept, or our initial weight. So I'm going to write y equals, and I'll replace the m with this 2. And the b, remember the b, if that represents Alan's initial weight, if I look at the table, his initial weight would be the weight represented at week 0. So the linear equation would look something like this. So I have y equals 2x plus 160. Right, so that's the equation that represents Alan's weight gain or weight loss over several weeks. And I just wrote this equation on the side just so I can take stock of the equations for the 3 friends, because I think we're going to need the equation that represents each of their weight at the end. So Alan's equation was y equals 2x plus 160, and I'm just going to write that on a spare piece of paper. Okay, let's move on to question 3. Okay, so it looks like Bill forgot to record his weight at the beginning. Remember, Alan had a weight at week 0, but Bill's weight, well, he starts at week 2, week 4, and week 9. So it says, what is the rate of change of Bill's weight? Well, again, we should probably record 2 average rate of change calculations, or find the slope twice to make sure they're constant. And that would be our answer for the rate of change. So my first calculation, I used the 2 points that correspond to weeks 2 and week 4. So my change in output was the 188 minus 194, and my change in input was the 4 minus 2. Right? So change in y over change in x, and that left me with negative 3 pounds per week. I'm going to do one more just to make sure the average rates of change are constant to guarantee that we have a linear function here. So I'm going to do this calculation again with 2 different points. So again, if I use the ordered pairs that correspond to weeks 4 and week 9, you'll notice I have 173 minus 188. Over 9 minus 4, and I end up with negative 3 pounds per week. So I know we have a linear function because my slope, or my average rates of change, are constant. And it looks like the rate of change in this case is negative 3 pounds per week. So they say, okay, what was Bill's initial weight? Consider the rate of change. What was his weight at week 0? Well, think about this. If he was 194 pounds in week 2, and he lost 3 pounds every week, that means he would be 3 pounds heavier in week 1. So I'm going to modify this table for a moment. So I took this table and I just added two more rows, right, to represent week 1 and week 0. So if Bill was 194 pounds in week 2, he would be 197 pounds in week 1, right? Because if he's losing 3 pounds per week, that means each preceding week he'd be 3 pounds heavier. So in week 0, he would be 200 pounds. He loses 3 pounds to come down to 197, loses 3 pounds to come down to 194, and now he'd lose 6 pounds, right? Because he'd lose 3 pounds going into week 3, and then another 3 pounds going into week 4, and so on. So I think Bill's initial weight would be 200 pounds. So I'll just write my answer. Bill's initial weight was 200 pounds. Let's take a look at question 5. Write the linear equation in the form of y equals mx plus b that describes Bill's weight. So again, we know Bill's initial weight. The b is the 0. So at week 0, that's Bill's initial weight, which is 200 pounds. We know the slope, the m, that's how many pounds he lost each week, which was the 3, right, the average rate of change. So we can write y equals mx plus b. We have all the components we need. So there's the equation that represents Bill's weight over time. Question 6 says obtain graphs of their weights from weeks 0 to 10 on your graphing calculator. So we have to open up our calculator. And let's see if I can make this a little bit bigger. Let's see, size, we'll try large. That's not much bigger. Okay, so Alan's weight, I think I wrote that down on a separate piece of paper. Right, Alan's weight was y equals 2x plus 160. So under my y1, I'll type in 2x plus 160. And Bill's weight was the negative 3x. Now remember, it's very important that you use the negative key and not the subtraction key. The negative key is under the number 3. So negative 3x plus 200. And the book gave us a little hint here. It said from weeks 0 to 10. So when I press the window key, I'm going to start at 0. So x min will be 0. And we'll go out to 10. And then in terms of y represents the weight, right? So I'll put a minimum weight of 0, even though we know no one's ever going to weigh 0 pounds. And we know that Bill's initial weight is 200 pounds, so my y max maybe should be a little bit bigger than 200. I'll try 225. Okay, and if you wanted to change your scale, this y scale, that would be if we wanted to count by 10s or 20s, that's fine. If you leave it as 1, that's fine as well. I press graph, and you'll see on my x-axis, I'm counting by 1s. My y-axis, I'm counting by 10s. And this is a graph of Al and Bill's weight. Now you might say, well, which line belongs to who? Well, if Bill's initial weight is 200 pounds, and if you remember Alan's initial weight was 160 pounds, Al would be on the bottom, right? Because at week 0, he's at 160 pounds. And Bill would be on the top, because at week 0, he weighs 200 pounds. And Bill was losing 3 pounds every week, while Alan was gaining 2 pounds every week. All right, so I think we'll stop here. Look for part 2 in Canvas, and we'll complete problem 7 and on.